All right, here we go. Lesson 2, part 2. So here we go. So what we got to do is we first got to graph this out. And what we want to do is, and then we're going to walk through the back side of this. So a physics instructor wants to find the relationship between mass and acceleration. Instructor begins with a 1 kilogram mass on a cart and measures acceleration after being shot out of a sling. He then increases the mass and measures the acceleration for different masses. Examine the data below. So first of all, we need to find the independent and dependent variable. So in this situation, he measures the acceleration. That's the one being affected. So that's my dependent variable. So that's my y-axis here. So increasing the mass, he manipulates that, and so that's our x-axis. So that's our x here. All right, so we're going to graph these. This on the independent on the x, and the acceleration on the y. So you got to keep it in scaling, and we got to make sure we label our axes here. Okay, so we'll go ahead and label these in the appropriate ways, and I'm going to go ahead and just do several of these things without the video on. So you'll come when I turn it back on in just a second. You'll have some things recorded. Wow, that was fast. So I go ahead and took the liberty and graphed this. This should be a review for you. And again, I just scaled it down here across the bottom to 7, jumping every 2 so it fit nice. And then I plotted each point, and then I created a linear line. All right, so go ahead and fill that out, and then let's go ahead and try this. So write a sentence describing the relationship between mass and acceleration. Well, this one's a little bit different than our last example. This one, as mass increases, acceleration actually decreases this time, which is different than the last one. The general equation of the line is simply y is equal to mx plus b. It's a straight line. Next unit, we'll do things, or 2 units from now, we'll do things that aren't so straightforward. So now let's go ahead and replace x and y with the names of the variables I graphed. So on the y-axis, we had acceleration. I'll just shorten to accel, equals m times mass plus b. Okay, so it says, what is the value in units of the slope? Okay, so let's go back here and do our calculation here. So in this situation, we're not going up now, we're going down. So we're going down 2 over 1. Down 2 over 1. So since it's sloping down, it's actually a negative. So you're actually going negative 2 over 1. Now we need units. So that's negative 2 meters per second squared over 1 kilogram. Okay, so now we need to shorten these units up. This takes a little bit of algebraic manipulation. This is actually kilograms over 1. So if you take meters over second squared times the reciprocal of what's the bottom, 1 over kilogram, what you end up with is a unit that says meters over kilogram second squared. This is my unit for my slope. So my slope is negative 2 meters over kilogram second squared. And again, if you want me to slow that down and show you the math of that, I'll do that on Monday. That's not a problem at all. So the meaning of my slope. So what my slope is, it's the ratio of change between acceleration and mass. So as the mass increases, it says your acceleration. Number 7 says m. Now let's go ahead and plug it into our equation here to this. So we got acceleration is equal to negative 2. Now include your units. Meters over kilograms second squared times our mass plus our y-intercept. Now it says, what's the value and meaning of your y y-intercept. So we come up here, and our y-intercept is crossing at, there we go, 14. So let's come down here. So that's 14 meters per second squared. Okay, so what does the y-intercept represent? It's the value of acceleration when mass is equal to 0. Again, just like we learned a few minutes ago in the previous lesson. So now let's go ahead and put this all together. So A is equal to -2 meters over kilogram second squared times mass plus 14 meters per second squared. All right, now notice, again, the trend is no units, yes units, no units, yes units. You want to follow that trend. That'll be a tricky thing that I'll be getting a lot of you on points-wise. All right, number 11 says use this equation to determine how much mass until there's 0 acceleration. A lot of you can just look on the graph and see here's 0 acceleration, so how much mass? 7 kilograms. Let's try it using our equation. We already know the answer. So 0, we'll go ahead and plug in our values into here now. So we got 0 is equal to -2 times mass plus 14. So we want to get the mass by itself. So we subtract both sides by 14, -14. So you get -14 equals -2 times mass. So divide both sides by -2. And so what you get is a mass is equal to 7 kilograms. All right, so there you go. That lines up with what we know. Okay, number 12 says, using either your equation or your graph, determine the acceleration if there is only 0.25 kilograms of mass. All right, so again, we'll go back to our equation. So you can look, and we can look at the graph. So if there's 0.25 time, that's right in here, it's going to be somewhere closer to 14, greater than 13. So somewhere between 13 and 14. So we just go ahead and plug in our equation. Acceleration is equal to -2 times 0.25 plus 14. So -2 times 0.25 is going to be -0.5 plus 14. So acceleration is -13.5 meters per second squared. And make sure you include the units. All right? Well, that's all. Look forward to seeing you on Monday. Come with questions. If you want to try worksheet 1 or worksheet number 2, go for it. If you want to go ahead and try one, you can do it. Then you can come with questions in class. If not, we'll just work on it together in class. So have a great weekend. See you on Monday.